come to this session. Out of curiosity, does anyone here read my blog, Virtual Geek? You know, I'm always straggling Duncan Epic in the blog counts. You know, the most popular VMware-related blog. So please, everybody, go and check it out because I want to beat Duncan, author of Yellow Bricks. The only reason I bring it up actually isn't for that egocentric thing. I find someone pushed me hard into doing the blogging and tweeting thing. It's very weird, but it's a great way for us to have an ongoing dialogue beyond the contents of the session. The other reason I point it out is historically I always run over schedule. So there's going to be a lot in this. I'm going to try to finish it up as quickly as I can so that we can have some Q&A time at the end, which I think would be great. If we for whatever reason run out of time, you can come and grab me afterwards out here at the front or outside. And if not, we can continue the dialogue on the blog and on Twitter. So first things first. Just again, as people continue to sit down, show of hands, how many of you are EMC customers? And how many of you are not EMC customers? Great. So to the first group, thank you. To the second group, you know, hopefully we can persuade you over time, but again, that's not going to be the hyper-focus of today's session. How many of you are VMware customers? Right? So again, you know, guys, customers make the world go around for both VMware, for EMC, so thank you very much. Today's discussion is going to be around next generation storage and backup for your cloud. You got to have the mandatory cloud word in there, but really what we're talking about is where is VMware forcing us as EMC and the broader ecosystem of people who build storage and backup products. Where are they pushing us? In other words, where are you guys, the customers, pushing us? Architecturally, what's changing? What does that mean to our roadmaps? And again, I'm going to try to keep this, there's inevitably going to be some EMC stuff in this, but I think a lot of the content in here applies across the industry, so I'm going to try to make it as useful whether you're an EMC customer or not. So without further ado, let's get started. Yes, this session may contain secret information, which I'm a leaky sieve. Therefore, I need to always put up this slide. And I'll try to always highlight what's now, what's a future, what's a roadmap. But it's all very blurry for me. But for those of you that don't know me yet, I think I've got the coolest job in the world. At EMC, I'm Mr. VMware, so my job is to make sure, fundamentally, that EMC is a great choice, and hopefully the best choice for customers that are using VMware on our own merits, right? It's very important to invest our R&D, our go-to-market efforts, but in the end, ultimately, I'm lucky in the sense I get to be in the center of the IT known universe, right? Cloud virtualization is where it's at. And unfortunately for me, that means that today, tomorrow, 2 years from now is all a blurry continuum, right? Because here we are talking about vSphere 5. vSphere 5 was feature complete at the end of VMworld 2010, right? So, and now we're going through future versions of vSphere, going in future feature lockdown and all that stuff. So it is a little bit blurry. So I have to really make sure I put this slide up. This is going to be the flow of the discussion. Big idea, how that affects backup, and how that's affecting storage. So the big idea is that disruptive technology creates lasting change, where giants collapse if they're not able to adapt. Right? Examples of disruptive technologies were bridges, the arch, right? Trains. Someone gave me an earlier example today that I thought was kind of cool, which is ice. It used to be that you would literally, the way you got ice is you went out and hopefully you lived in Canada like me, or maybe in Denmark or somewhere else in the north, right? And you'd go and you'd cut a hole in the ice and you'd take your ice, that's how you got ice. And then someone said, well, we could pack it in straw and ship it a little bit. And then whole industries came up about localizing the ice cutting shipping business. And then somebody invented a refrigerator, right? And the number of leading ice cutting shipping companies that made it into the refrigerator era was zero, right? And so what's important is each one of us as individual enterprises or as EMC or anybody need to perpetually be very, very laser focused on where is there a disruptive change occurring, because if I'm not careful, that could be me, right? So examples, you know, the latest examples around this, by the way, are virtualization, commoditization of compute. In other words, massive multi-core, low-cost processors from Intel and also AMD. The emergence of flash, right, as a low-cost, extreme high-performance storage medium, right, and cloud consumption models from service providers as well as in the enterprise. So if you look at it, you go, okay, now how do those things change backup and storage? On the backup side, the latest state-of-the-art, right, is to leverage all the stuff that's in vSphere 4.1 and in vSphere 5 to improve the speed of backup and recovery, right? So this is the vStorage APIs for data protection, change block tracking, those sorts of things, right? The other thing that is important is that we found that in the early days, and I think that most customers are kind of past this now, in the early days, backup was an inhibitor to virtualization progress. In other words, if people couldn't support the backup and recovery SLAs for some application, you know, the application owner would say, and therefore I don't want to virtualize it. But they were always looking for an excuse, right? Most customers I talk to today in Europe, as well as in the Americas and in Asia Pacific and Japan, most customers have kind of moved past that. They figured out how to crack the nut of backup and recovery and virtualize mission-critical apps. And then the latest thing that we're seeing more and more demand around is to support not just for vSphere and vCenter integration, but integration with vCloud directly. So just out of curiosity, do we have any Avamar customers in the room? As a whole, how is it? Good, bad, happy, unhappy? You can yell it out. Good. So I got a good. Another hand there in the back. You want to yell it out?
Rocks.
It rocks. So, you know, whether or not you're using Avamar, if your backup vendor doesn't have vCenter integration, doesn't do vStorage APIs for data protection for backup and recovery, like something is wrong with them, right? We're now past the point where more things are being deployed as virtual machines than as physicals. You know, if you're still basically deploying agents around to everything, that's not cool, right? So the key result in that, and again, this is an Avamar example, but the same thing would hold true of other backup vendors that integrate and use these APIs, is literally, you know, the example that we highlighted is backing up 1,000 VMs in 43 minutes, right? That is really, really, really fast. We've done scenarios where using change block tracking, we can do a full VM restore in 10 seconds for a 100 gig VM, right? So again, in this, we don't have too much time in the session to go into it in agonizing levels of detail, and there's lots of good sessions at VMworld to learn more about this. The key thing, right, is that in vSphere 4.1, they introduced change block tracking. Change block tracking allows you to basically say, instead of backing up the whole VM, I'm going to basically only back up change blocks and therefore speed up my backup process. Some backup vendors, Avamar being one example, can also do a dedupe on that data. So not only is you're only backing up what's changed in the VM, you're only backing it up, you know, once for blocks that also coexist on the same ESX host, right? The other major challenge that customers have with backup and recovery is everybody hates in-guest agents, right? As much as possible, you want to not use in-guest agents. Keeping the guest image as simple as possible is a general design goal for everybody. Keeps it small footprint, makes it operationally simple. There's certain scenarios where no matter what, you're going to need an in-guest agent, right? Those examples are applications that need special log handling during backup and restore processes, or are applications that have lots of relationships, right? So if you're going to use Exchange, you know you have to have an in-guest agent to do log replay during certain operations, as well as SQL Server, SharePoint, Oracle, and others, right? Make sense? But for every one of those, you got a bunch of craplication VMs, VMs where you don't need that, and you're fine without application integrated backup and recovery. With vSphere 4.1, VMware added the SCSI hot add process, which allows us to use that to not need to install an agent inside the guest, so that you have a proxy on the ESX host. You know, the early efforts with VCB. Any people went through the VCB experience? How'd that go?
Bad.
Early efforts were not so good on the VCB front, right? But what we found is by the time that we got to the vStorage APIs for data protection and SCSI hot add, removing the proxy, in general, people's feedback around that has been very positive. And we're finding is more and more customers are not using agents in general, right? Which is good. But the latest state of the art is that with vSphere 4.1, you can also use change block tracking on restore, right? So change block tracking normally just helps with the backup process, but you can actually use it, and not all backup vendors use this, so if you're looking at a backup vendor, it's worth asking, like, how do you use this during the restore process? It can actually make sure that when you're doing a full VM level restore, you can actually just stream the delta blocks back into the image, which can make very, very fast restore times too. Make sense? I often get asked the question of, what's the right way to do backup and recovery? And it's a long, long conversation. The answer is it depends for every customer. As any good engineering type will tell you, the answer is never black and white, right? In general, array-based snapshot approaches are an excellent, oh no, I just deleted something, recovery mechanism, right? Which is basically instantaneous full VM level restore. And most array vendors today can take VM level snapshots and do VM level restores. But what people always miss is who here is a backup administrator, right? For those of you that didn't raise your hand, there's somebody in your company that is the backup administrator, right? And if you ask them, how often do you need to recover the whole VM? The answer would be, well, sometimes. And usually it's within 5 minutes where someone says, I just deleted something, please save me, right? The vast majority of the time, the request comes in the form of, hey, I deleted a file inside this VM, can you restore it? What file did you restore? What file did you delete? I don't know. It was foobar.txt. When did you delete it? I'm not entirely sure, right? And you're just like face palm, but it happens, right? So the point is that array-based snapshots generally don't do a good job of cataloging long-term backups and long-term retention. So in general, array-based snapshots are a good complement to a backup strategy, but not a backup strategy unto themselves, right? Now, where things are going is really around this vCloud directional use case. So before we get to that one, what customers started to tell us more and more is they wanted more vCenter integration. Who here's a VMware admin? Some people are lazy and don't want to raise their arm. There's more than you in the room, I'm sure. But the long and short of it is that sometimes the backup team wants to have their own console, but sometimes the VMware team wants to be able to do their own backup and recovery directly from within vCenter, right? But the other thing is that even if you don't want to do backup and recovery within vCenter, the backup team needs to be able to go and say what VMs have been backed up, which ones haven't. Were they full VM backups? Were they in-guest backups? Did they successfully complete? And change block tracking needs to be easy to enable for loads and loads of VMs, because the backup admin needs to see, hey, have new VMs been created that haven't been backed up? So one thing that we've been doing for a while is we basically have integrated Avamar into vCenter APIs, right? Which means that Avamar itself will map out what VMs have been backed up and which ones haven't. Where we're taking this next is we're making it so that when VMs are created from within vCenter, they automatically create the backup process, right? So that it doesn't require this kind of closed loop and audit. Make sense? Again, I'm not trying to make this like go Avamar, even though I think Avamar is a great solution. Regardless of whose backup product you're using, if they're not using the vStorage APIs for data protection, if they're not using change block tracking, if they're not doing deduplication, if they're not integrated with vCenter, your backup vendor doesn't get it, right? So the next thing is dedupe, right? Again, whether it's our technology or not, dedupe is now a must-have for backup. Dedupe comes in two flavors for the backup use case. Source-based dedupe, where you're deduplicating the data before it gets sent to the target. And then target-based dedupe, where basically the data is being sent, usually over a network to a network share, it gets dumped in there, and it gets deduped in the process. A lot of confusion around these, and again, I'm not on the sales side, but I get to see a lot of vendor positioning as part of the process. The way I think about it is I go, one has a certain advantage, which is you transmit way less data, right? And that has an upside, right? Because you're deduping the data before it goes to the target. The challenge with that is invariably, if your backup software doesn't do it, it requires a change in your backup software, right? The target model, where you're just throwing it into a backup target which dedupes the data, is useful because you can use that with pretty well any backup software on the planet. But there's also one other core architectural difference between the two. Source-based dedupe is CPU intensive, right? So in the early days of Avamar is an example of a source-based dedupe. It was possible for it to chew up lots of CPU cycles while it was doing the dedupe. Over time, we changed that so you could throttle it, and it would spread it out. It would spread it out across the vSphere cluster, right, to balance the workloads. But the other thing is that it takes time to dedupe the data and send it. And for really big, very hot data sets like databases, its performance generally doesn't, it struggles to back up huge data sets with very, very large transactionally like VMs. And that's a place where the target dedupe has its fit. And in the EMC portfolio, that's data domain. Do we have any data domain customers? How's it going? Want to yell it out? Good, bad? Good? Simple, easy, right? You put it in, it's a target, you throw stuff in there, it gets deduped. So the latest thing that we're seeing, we're doing it, and other people are doing it too, is they're merging these ideas, where basically the backup software is smart enough to go and say, this should be a source-based dedupe based on the data set, and this thing here, it's a big transactional database, I'm going to not do the dedupe on this side, I'm going to send it to the target. Right? So we're unifying these models of source and target dedupe models, because ideally you want to dedupe in the right place automatically all over the place. Now, do we have any VCD customers in the room? vCloud Director? Anyone using VCD? How's VCD backup? Pause. So I'll help, right? There's no good answer today for vCloud Director backup, right? VCD has a whole slew of stuff. Yeah, you need to be able to back up and recover stuff inside the VMs that are being deployed in vCloud Director. But you also need to back up the catalog of virtual machines that could be deployed. The information is in vCenter, so if you're using vCloud Director, you go and you start to see all sorts of resource pools with weird names being created all over the place. And then there's stuff that's actually within the VCD database, right? So a backup and restore would have to include all of those things orchestrated if you want to recover a VM. And if you're a service provider, are you a service provider or a customer, or an enterprise customer?
Service provider.
If you're a service provider, you also have to think about tenancy. In other words, how do the tenants recover themselves, and how do you make sure that if this customer needs to be restored, you don't accidentally step on the other customer over there, right? So it's still early days, as you can see from the number of hands that go up around VCD, and VCD has also changed a lot from 1.0 to 1.5. But Avamar did a whole bunch of these things. And we did it for some service providers, and we wrote it up in this big honking white paper, right? That people said, okay, that's cool, but we don't want to consume it that way. Some service providers are using it and kind of home brewing it. What's coming next, and this is a preview of something to come. So, warning, this is now a future, right? Is something that we've been working on with the VMware team to provide a simple and easy multi-tenant backup for vCloud Director use cases. So if you log in, and one thing that's kind of cool is, has anyone tried this in the hands-on labs, the VCD stuff? I'd encourage you to check out the hands-on labs, they're great. If you take a look, this is a very similar look and feel to vCloud Director. So it brings up automatically what tenants are in there, what orgs are in there, right? This is being done because we're automatically querying into the VCD APIs as well as the vCenter APIs. But the other thing that's cool is notice that it not only kind of like has the same structure, it even like looks and feels the same. One thing that's cool is both EMC and VMware are moving towards common Adobe Flex-based UIs. So you'll see like our UIs even kind of start to look and feel similar. So if we pop back to this, you create a data protection policy, and the data protection policy can come in like gold, silver, bronze, SQL Server, whatever, and those can get assigned to tenants. Now again, if this makes it sound like all this discussion of multi-tenancy makes it sound like it only applies to service provider, it doesn't. Most enterprises have concepts of tenancy or customers within them, right, where the IT organization is providing a service to the tenant. So if we take a look here, we've got Dinoco and BNL. These are made up customers, Monsters Inc. And you can see that each one of them has a default backup policy that's created with them. What that means is that customer when they log into vCloud Director and they create VMs, the VMs will inherit that backup policy automatically as they're created. Does that make sense? Now, as you kind of go through this example and we click on the bronze SLA, you can see, okay, that those are the customers that are using it. Here's the basic policy that's been ascribed. And as we go through and we actually create stuff, that backup policy is going to be applied against every single VM automatically. Where we're going to take, by the way, it's not part of this early prototype, but the next wave prototype, one thing that we've done is we've made it API programmatic so that the customer themselves could provision their own backup service. Right? So backup is a service with full-blown self-service models, which is pretty cool. If we go in here, we've got a series of individual VMs. And you guys notice that I could change the backup policy however I want it, right? So they can go in and they can customize it. What we're going to do, as you can probably imagine, is we're going to go through and we're going to take a look at one of these VMs. Here are all the backups that were taken. They're happening on a regularly scheduled basis. And we can go and create an on-demand backup. Now, by the way, this Avamar vCloud Protector prototype that we've developed leverages all of that stuff we were talking about. So all the developments that we've made around how to leverage VADP, the vStorage APIs for data protection, vCenter integration, change block tracking, all that sort of stuff. So we're just continuing to evolve around this model, right? So for example, here I'm creating an on-demand backup. I can specify either the default or I can do my own, and boom, off it goes, and we back up that particular VM. Now if I go back over to vCloud Director, and we take a look, you can see that this particular VM is currently up and running and happy, right? So you can probably, again, imagine what I'm going to do next, right? We're going to trigger that Backup Now button, click, right? Again, in this case, when we were doing this work, this was a 100 gig VM, right? And the backup, literally, this is a real-time, how long it took to trigger a backup for a 100 gig VM. It's like about 10 seconds. Now, we pop back, and we intentionally had blue screen the VM. Right, so pop back over, hey, that's not good, right? So what we're going to do is we're going to pop back and we're going to do a full-blown VM level restore. Remember, no agents were involved in this process, and this could be done programmatically by the tenant themselves, which would be really important as you guys start to use vCloud partners like Colt and others, right? You're going to want to be able to control your own backup destiny for the stuff that's sitting out there in the public cloud. So as I go in and I say, boom, I want to do a restore. Again, 100 gig VM, in-place restore, no agents, about 5 to 10 seconds. That's a fast backup. That's a fast restore, right? And the VM is already back up and running. Does this make sense? So again, the future of backup has all of those things along with deep vCloud Director integration, offering backup as a service. And I think you can expect to see more and more stuff around that backup direction. The other thing that you can expect to see is continued development around VMware's own native backup tools and capabilities, right? So VDR continuing to expand out what it does. So now transitioning briefly over to the storage side. On the storage side, I love the furious interplay between all storage vendors about what feature drives efficiency. What do you guys think saves money when you're using storage? Feature-wise. Dedupe, tiering, simplified management, caching. Right? These are all true, but every vendor trips over themselves, us included, to go, no, it's the ones that we've got. Those are the ones that are the most important to you, Mr. Customer. All of the other stuff doesn't matter, right? It starts from a very fundamental observation from a tech. What is the measure of efficiency when it comes to storage? Anyone want to take a brave guess in our intimate audience? Utilization, which is a measure of dollars per gig, right?
Stuff that is really on there and that I really have to use.
Is it really out there? The stuff that I really need to use, is it there?
I'm quite sure I found it. That's the information that I want.
Availability, of the stuff that's really important. Those are all important measures. People tend to focus too much on the dollars per gig metric. And now I'm going to step out of my EMC, life and put this more broadly. there are 3 separate dimensions of storage efficiencies and technologies. These apply to every storage vendor on the planet. And any storage vendor that says to you that some of them don't matter, and we've done some. The reality of it is, behind closed doors, count on it. Their engineers are working furiously on it, right? So, down the capacity angle, the technologies that are driving efficiency, measured in dollars per gig, or watts per gig, or U per gig, space per gig, right? Square feet per gig, are big, cheap SATA disks, right? It's not sizzle, right? It's not all exciting and sexy to go, hey, you can now buy a 4 terabyte or a 3 terabyte SATA disk for the same price that you bought a 1.2, 1.5 terabyte SATA disk last year. But it costs the same, it uses the same space, therefore it's twice as efficient. Does it make sense? And literally we're seeing more and more customers starting to use big honking SATA disks. The storage spindle vendors that we all use as storage vendors, they have a clear line of sight to go from 3 terabytes, which is kind of the current state of the art for the most part, to around 6 terabytes, for a 3.5-inch spindle. And then after that, they have no idea how they're going to get more dense. Now, that's not to say that they might not, make another leap. But basically, looking at all of the technology roadmaps, they see the road to get there, but then not past, right? The other thing that's going on is the overwhelming use of thin provisioning. At the VMware layer, the storage layer, again, furious debates about what's the right place to do it. The right answer is do it as many places as you possibly can operationally, right? So if you can only do it in one place, it's more efficient to do it in the storage layer because the pool of thinness is larger. But thin on thin works fine, right? Again, the only thing you need to do is monitor it at the storage layer, monitor it in vCenter. Every storage vendor worth their salt has thin provisioning thresholds, alerts, those sorts of things. You've got to just use them, right? Who here is using thin provisioning at the storage layer? That should be everybody. Thin provisioning is the de facto storage model from not just EMC, but all of our storage vendors. Dense. So what do I mean by dense? For certain customers, the biggest question is how many petabytes per floor tile, right? So the current state of the art from EMC is 1.8 petabytes raw per cabinet, right? We do that by having a 4U enclosure that has 60 spindles in it that are kind of vertical, so it slides out in a tray. We actually needed to design the whole cabinet such that it was impossible to roll out 2 trays at once, otherwise it would fall over and crush you, right? But the point is that density is also not sexy, but for certain customers it's really, really important. So I saw the prototype of our 120 spindle in 4U enclosure. Right? So density is going to continue to increase down this path. Currently, 3.5-inch disks are the cheaper one per density, because you can get a 3 terabyte, 3.5-inch disk, but you can only get about a 600 gig to a 900 gig, 2.5-inch disks. But again, the spindle vendors are all going to transition to 2.5-inch spindles over time, at which point we can fit 120. But it'll blow your mind. I've seen the prototype of 1,000 spindle 4U enclosure. What the? Like, how do you do that? The answer is, as people start to move towards flash, it doesn't have to look like a physical spindle, right? So again, there's going to be this continued march down density paths, which is very, very interesting. And then primary storage compression and deduplication, right? Expanding out dedupe to not only cover the backup use case where it's pervasive, but starting to increasingly use it for primary storage models as well. Now, everyone looks at that and goes, I understand those. What people don't think about is that for many workloads, efficiency isn't measured in dollars per gig, but dollars per IOP, right? In many cases, to achieve the level of performance that you need, it's all about IOPS, not gigabytes. So for example, for the hands-on labs, the single storage vendor feature, which is the most important, is not dedupe or dense or thick, it's flash. Right? Because for that lab, we're creating and destroying, 10,000 VMs a day. It's not about gigabytes. It's literally, can we make you guys all happy by having a good user experience, which is about performance. Does that make sense? So the features there that matter are massive multi-core. So what do I mean by this? Again, raise your hand if you're an EMC customer. Do we have any VNX customers in the room? Clarion customers? Give me a Clarion customer. Okay. So I'm going to pick on you since you're right up in front, right? You're running vSphere, right? What version of vSphere are you running?
4.0.
4.0. And your average vSphere cluster, how many nodes do you have? In other words, is it an 8-node cluster, a 10-node, 4-node?
12.
12 nodes. Okay. What kind of CPUs are you using? What kind of hosts? Are they HP, Dell?
Yeah, HP ProLine blades.
ProLine blades. So they're like 460s?
Yeah, 490s.
480s?
90s.
490s. So basically you have on each blade probably between 8 and 16 cores.
Yeah, more or less. They differ.
They differ. So let's just use 10 for easy math, right? Even though they're not 10, they're going to be 8 or 12, depending on, or 16, depending on which one you're using. So if you think about it, basically VMware has now made it unbelievably powerful to be able to get 10 times 12, 120 CPU cores in a modern, simple vSphere cluster. Awesome, right? And you're attaching that to a Clarion CX
380 and a 480.
a 380 and a 480, right? So basically there's 1/4 as many CPU cores in the storage subsystem as there is in this vSphere layer, right? And again, I'm highlighting the EMC example. The same thing holds true of everybody else. What's occurring is that Intel and Intel's on the upswing. There's always the battle between Intel and AMD over time. Has made it so cheap to get massive multi-core systems that the compute power of the host is starting to outstrip the compute power in the storage subsystems. Now, storage subsystems don't have to have as much CPU horsepower as the compute layer does, but if it gets too out of whack, there's a problem, right? So storage vendors all over the place, us and others, and thank you for being an EMC customer, have to strive furiously to figure out how do we build commodity mass multi-core into our storage designs, and how do we rewrite the code that makes the arrays work, because arrays are software more than they're hardware. How do we rewrite that so we can actually massively multi-thread? Does that make sense? If we don't do that, all of a sudden the host will outstrip the storage subsystem, right? Another example, thank you for being a willing participant in my example. The next thing is the emergence of 10 gigabit Ethernet. How many of you are using 10 gigabit Ethernet in your environment today? 10 gigabit Ethernet has now moved out of the weird and into the mainstream, right? And 40 gigabit Ethernet is now starting to exit its crazy phase and start to see people actually ship products. And 100 gigabit Ethernet is right around the corner again, right? While fiber is not going away, in fact, we're also seeing the 8 gig to 16 gig transition, right? We're seeing more and more people looking at converging, using FCOE, using iSCSI and NAS. It doesn't really matter which way is the right way for you. Again, we can have discussions over a beer later about, which way we're seeing customers go. And the answer is it depends on you and your environment, right? But we're seeing more and more customers go, I'm going to use Ethernet as my primary storage interconnect, which simplifies things and lowers costs, which is great. Next one is the commoditization of SSDs. So I'm going to try another fun experiment. We're going to make this a strange session, right? Who here uses an SSD in their laptop? Does anyone who raised their hand want to give it up? No. I would need to fight you to get it, right? So, why? Because the experience is so much better. Your machine boots faster, it's more responsive, it's better. Now, why didn't everybody raise their hand? Because it's expensive, right? What's that? We got the pro Apple. I'm with you, brother. So the key thing here, right, is it's more expensive, but it's more expensive when measured in dollars per gigabyte, right? In other words, you can buy a 256 gig solid state hard drive as a consumer for around $500 US. Right? Rough and tough, right? Now, if you think about it, by the way, that same hard drive didn't exist a year before. The 128 gig version of it cost $1,000 a year ago. So the price curve is dropping by an amazing factor over the last 2 or 3 years. Now, the other thing that's important is Is it cheaper or more expensive? Flash.
It's more expensive.
It's more expensive, right? No, it's not.
No, it's cheaper.
Exactly. Down the performance axis, you guys are now getting it, right? It's 100 times cheaper than a spinning magnetic media. In other words, you can do basically thousands, and in some cases tens of thousands of IOPS out of a device where the analog on the SATA side can only do 80. You know, 5,000, 10,000 IOPS versus 80, right? Does it make sense? Now, EMC's been shipping solid-state drives and the arrays for 3 years now. And they're very, very robust. These are different than the commercial SSDs. They use something called SLC technology versus MLC. But MLC will start to show up more and more in enterprise arrays too. It's just a matter of timing and maturity. But when we first came out with it, our marketing was terrible. We said 30 times faster for 10 times the price. Right? Who wants that? Well, some people are like, no, this workload, if I could make it 10 times faster, or 30 times faster, I'll pay 10 times more. Through the magic of mathematics, wouldn't it be better had we said, I'll give you the same performance for 1/3 the price? That's the exact same expression. Right? You know, the difference between math and marketing. So the point is that this commoditization of solid state is not going to stop. In fact, our expectation is that as we get towards the end of 2012 and into 2013, there will be no economic room for 15K RPM disks of any type. In other words, the dollars per gigabyte for high-performance magnetic media will be the same as the dollars per gigabyte for solid state. At which point, storage arrays will no longer have any reason to have drives that are high-performance magnetic media drives. You only have the really big SATA, and you only have the solid-state stuff. Does it make sense? Looking even further out into the 2015 window, there will come a point where there won't be any space for magnetic media in primary storage at all. In other words, remember how I said that the magnetic media vendors are saying, yeah, we can get to the kind of 6 terabyte window, and then after that we're going to need to invent something, right? The people who are building solid-state drives, Samsung, Intel, and others, they can leverage Moore's law to keep producing it cheaper, smaller, more and more dense. Now, eventually they'll run into their own limits, but it's a little bit further out. So we're going to be in this interesting transition where today, tape on backup is being replaced by disk with dedupe. Primary storage is moving from mostly 10 and 15K RPM to all SATA and some flash. And then eventually what's going to happen is disk itself as magnetic media will become obsoleted by just all flash arrays. Does that make sense? As opposed to something weird, something mainstream. Then you get into furious debate land about how should you use solid state. Should it be a cache? Should it be a tier? Should it exist in the server? Should it exist in the array? And the answer is it's going to exist everywhere. Right? So, anyone who says that it's going to just be one answer is high. Right? So really the answer is it's going to literally affect and transform everybody. So having very large-scale caches within storage subsystems and in the server using solid state is going to change the whole market. And then since we're clearly in a state of transition, going from this model, the idea of auto-tiering, being able to move data from solid state to SATA and SATA to solid state as needed is very important. It lowers the cost per IOP. Some people go, well, when we get to the all-solid state, will there be any value in auto-tiering? And the answer is yes. You know why? Because there will be MLC-based solid state and SLC-based solid state. And then there'll be magnetoferric memory solid state and DRAM solid, in other words, there's going to be a continuum of just all solid state memory technologies used in storage subsystems that are non-volatile. But all of that stuff, people tend to forget this axis, the flexibility axis. When you ask people that comes to this question of, do I have access to what I need when I need it, right? Because if you don't, all of a sudden, its value to you diminishes to near zero, and you're very angry. And bad days in storage land are very bad, right? So I/O modularity and multi-protocol models are very important. So one thing that we did is we designed in the storage subsystems the ability to hot add and remove different ports, so you can go from 5 to 10 gig, in a way that's non-disruptive. The ability to do non-disruptive everything, change file systems, LUNs, change anything in a way that's non-disruptive to the host, including being able to bring in a whole new array non-disruptively. Right? One of the most painful parts of any storage team's life is when the new array arrives. Right? Because they have to put in the new one, migrate all the data, then there's a huge painful cutover. Obviously, storage vMotion helps a boatload with that. But wouldn't it be awesome if there was a multi-vendor way to roll in and virtualize the storage without having something in the middle? So you could just roll it in and it would suck off all the data and then just automatically present it the same way that the old one did, in a way that's non-disruptive? That'd be awesome. Right? For many of our larger customers, it's pretty horrifying actually. They literally have teams that all their life are constantly refreshing. In other words, it takes them 3 years to refresh. And every 3 years they buy something new. Right? So imagine that horrible job. Right? It would not be fun. So one thing that we've been doing, and we've actually GA'd the first version of this, is the ability to non-disruptively move stuff from an old array to a new array without putting something in the middle. Because to put the something in the middle phase is always in itself disruptive. Right? But ultimately it's all about VMware integration. So it's not about one of these axes, it's about all three. That's the thing I want everybody to just think about and take away. Now, so let's get to the most important part. It's all about VMware integration. So what's state-of-the-art, circa 2011, VMware integration in a vendor generic way? First of all, most storage vendors today have created vCenter plugins. Does anyone here use vCenter plugins with their current storage subsystems? Does anyone here use VSI from EMC, if you're an EMC customer? Oh, it makes me sad. VSI is free. F-R-E-E, free. Right? I could, in any case. Now, what does it do? This enables people to do their own provisioning. And I'll do a demo of this later. The other thing that's going on is more and more vendors are starting to build VM object awareness within the array. So the array is aware of VM objects. We do this today across all the platforms that we do. The vStorage APIs for multipathing. This is something where the storage vendors can change the multipathing behavior of vSphere to improve availability or performance. The vStorage APIs for data protection, which is the VDK as well as other tools. APIs for SRM. Do we have any SRM customers in the audience? Site Recovery Manager. Right? So each vendor needs to build their SRAs that allow you to integrate this stuff. There's something called VAI that first showed up in vSphere 4.1. First on the block side. And now what's started to occur is there's now NFS-based offloads. Right? So storage vendors can now hardware assist NAS operations at the VMware layer. And then there's something where they can provide their own third-party VASA modules, which stands for the vSphere APIs for Storage Array Awareness. A long acronym, right? So all of this stuff, and then the other thing that storage vendors can do is they can cooperate with VMware to improve the NFS client, improve the core data mover code. Now, for customers here who are using vSphere 4.1, have you guys seen any effect of VAI in your environments? Has anyone seen that? Yes, no? Is it good, bad?
For me, it was very bad.
Yeah.
Because the array didn't toggle everything, so it went down.
So the VAI experience on the whole, right, for most customers has actually been quite positive. Just again, one thing I get to see is I get to see all sorts of customers around the globe, but that's not uncommon. So what I wanted to highlight is I said, hey, look, lots of improvements in terms of, how much time does it take to deploy a VM? In many cases, 10 times faster. Storage vMotion, up to 10 times faster. And amount of bandwidth used in the wire, much faster. But speed of operation may vary. Right? That bottom thing in there. So, one thing that we discovered through the process of development of VAI was we need to change the way that we test and do this stuff. The question isn't just, does the array support the VAI offload? Does it support it properly at scale, right? So what type of array were you using?
It was down.
So I won't say it again because I was hoping you would say mean. Because if it was mean, then I could say, here's what we did, and blah, blah, blah. Because you know, we found this across a lot of storage configurations, right? So no vendor was innocent, right, through the process. I did write a big blog post on the topic, so if you just look, Google Virtual Space Geek, 3 pieces of bad news. You'll see a lot of detail on this, about how this works. Now, it continues down the path, and we're continuing to improve both the original VAI command set. There's new ones also in vSphere 5. So the first one was something called thin provision stun. Previously, when you filled up a thinly provisioned storage device, and it filled up completely, all the VMs basically would blue screen and die, right? Because the device would say, hey, SCSI write error. What's changed in vSphere 5, if the array supports this offload, is that it says, hey, I'll fill it up, and once it's full, I'll respond back and say, oh, I'm full, and you get a little pop-up in vCenter that says, this VM is stunned. Add more storage to the pool, and then you can unstun it. So more graceful out-of-space handling. Again, you should never encounter this if you properly set up data store management, as well as array-level provisioning. Then the next thing that got introduced is something called thin provision reclaim, right? So thin provision reclaim, all arrays can now do reclaim of blocks. They scan the whole volume and can reclaim all the stuff. The problem is it's done in a post-process. So without the API, as you created virtual machines, you create a bunch of VMDKs, they would write data down, and eventually it'd fill up, and if you deleted a VM, the space would be reclaimed at the VMFS layer, it wouldn't be reclaimed at the underlying block layer, right? What's changed is that now it uses something called a SCSI unmap. So as you provision, and then delete, it actually returns the space to the pool. Now, important update between VMworld Americas and VMworld Copenhagen, right? This feature has been, in effect, kind of recalled. All of the vendors basically had their certs removed for this function. The reason for it, by the way, and again, I did a big blog post on it, so again, if you're not subscribed to the blog, please read virtualgeek.com. I try always to be as transparent as we can about the good, what we're doing right, but also what we're not doing right, because I think it behooves us as the storage vendor community to tell everybody, right? What occurred is that in some cases, the reclaim is a post-process. So in other words, it would return the blocks back in a way that was slightly asynchronous. And almost every storage vendor does it this way. In some cases, it would take more than 10 seconds for a file to be deleted. Now, normally you'd say, that's not a big deal. If a file gets deleted instantly or 10 seconds, who cares? Storage vMotion cares. The last part of a storage vMotion process is to delete the VM, and that last step used to take 0 time because all you were doing was changing the VMFS pointers and stuff like that, and now it would take 10 seconds and it would occasionally time out. So not very bad, like, in the sense that the worst that happens is a SPMotion timeout, right? But in spite of that, out of the lessons learned out of the initial VAI stuff, both VMware and the storage vendor community are oversteering to make sure that we go, no, stop. There's instructions on how to do a workaround as well as across a cluster, some cool PowerShell scripts. Now, in the spirit of time, I'm going to skip this demonstration because I can see I'm behind schedule. If you want to see a demonstration of this, again, go on YouTube. You can search for thin provision reclaim, and you can see a cool demo. Now, how many people here use NFS storage with VMware? Well, that's too bad. It should be more, right? NAS and block are both great. The only people who say you should go one way or the other way all the time are people who are trying to sell you something, right? And usually the only thing that they have to sell, right? There's use cases for both. But in any case, we've added a few new things for NAS-based offload. So the first one is an NFS full file copy. So EMC and NetApp both have got the ability to create file-level snapshots and file-level copies inside the storage array ourselves, right? First of all, we expose this via vCenter plugins for view use cases and provisioning use cases and stuff like that. But ultimately, you don't want to do it via plugins. You just want it to be done from within vCenter. So the difference here is that it used to be when you cloned a VM or deployed a VM from a template on NAS, it would basically read the whole file and then copy it, right? What's changed now is that with the API, it goes in and it says, hey, I want to create a copy of it. All I'm going to do is I'm going to take foo.vmdk and I'm going to create it inside the array, a full copy of it, so it offloads the network. right? Now, it's still not leveraging the snapshot functionality that we provide on a VM by VM basis, so it's still actually creating a full file copy. There will be future vSphere releases that will be able to leverage file level snapshotting on NAS devices. In other words, dramatically faster clone deploy from template, right? The one thing that's very important to highlight is this is currently used only for clone and deploy from template. It's not used during storage vMotion operations, the same way that the Xcopy VAI thing on block is done. And again, trust me, I'm going to skip the demonstration here, but it's because there's a better demonstration coming and I want to make sure I hit the time. There's a secret API, right, called extended stats. This didn't quite make it, right? So expect to see in future vSphere releases, right? But basically the problem here is that NAS devices
I've got a video cam filming, so if you don't mind
report
just
back
being on
that
the right
says,
side a little
hey,
bit.
I've got a file,
Just like that, just like you were before.
How
So,
big is the
thank you very
file?
much.
It's 100 gigs, right? You know, that's how the NFS server would respond to anything that asks about how big is the file. The problem is that it wasn't really 100 gigs, it was less because they were leveraging thin provisioning or dedupe or compression or something like that. So with the API, basically the response back is much more rich. It basically says, hey look, you know, the file says it's 100 gigs, but it's really a sparse, thin file, so it's only consuming, you know, n amount of gigs. And by the way, I deduped it, so it's really only using 5, right? And that means that it's easier to see the picture of space utilization at the NAS level within the vCenter client. Now, it didn't make it into the VC client. But, just as an FYI, do we have any Solera customers or VNX customers? Just so you know, it's currently in the GA code. So, you know, Merry Christmas. You'll get to be able to leverage that over time. There's another one that did make it, NFS Reserve Space. So the other thing, like currently if you're using NFS, there's a few use cases where you can't use it. And that's where you have to reserve the whole file, right? So classic use case there is Microsoft clusters, where you have to use it, Windows services for clustering for quorum disks and the like. There's now the ability with a NAS device where you can actually specify inside the vCenter UI about how that works. Now, I do want to spend time on virtual storage integration. So this is the latest state-of-the-art. We're on the 5th version of our plugin, freely provided, right? And we're going to continue to innovate around this. So one of the biggest issues that we found around the vCenter plugins is where there was a VMware team and a storage team. The problem was that the storage team didn't want to delegate full access to the storage subsystem to the VMware team. They wanted to be able to kind of carve it off and say, you can just view, or you can provision, but you can only provision this, right? So what we've done in the latest version, and as far as I know, we're the only ones that have done this to date. More customers choose EMC infrastructure behind VMware than anyone else by a long shot. We have about 41% of the share behind VMware, and the next closest folks are below 20. So we get a lot of demands, and they come in all sizes, small, big, medium, whatever. So what we did is we created a utility. I'm currently logged in as the storage admin, right? Where I'm creating a thing that says, I'm going to allow this customer to have access to a VNX. I'm the storage team. I'm going to delegate it. I'm going to say, are they allowed to do block provisioning or NAS provisioning or both? Okay, fine. And then I'm going to say, what storage pools are they allowed to pick? Right? So in other words, I could say just this part of the array. The VMware team is allowed to do their own stuff. And then once you go through that, you basically create a file, and the file is the thing that they send to the VMware admin. Because previously, the VMware admin needed to put in the storage array credentials into the center. You guys see the problem with that? Right? All of a sudden, the VMware admins have got full credential rights to the array. Right? Some customers kind of said, hey, that's not cool. Right? So basically, you know, at the end, we gave a pool, we created a profile, we're going to export this as a file, and then the file makes its way over to the VMware admin. Make sense? Now, as we save this off to the desktop, boom, done, saved to the VMware team, it's network share, off it goes. Now, obviously, this file can't contain any of the credentials in clear text. That wouldn't be very secure, right? So what we're going to do now is we're going to switch over to the VMware admin's view and take a look at what they can do with that, right? So what the VSI, or the VMware Storage Integrator plugin, allows the VMware team to do is do any provisioning that they'd like on their own. They can either just have view rights, or they can actually do full-blown provisioning if they'd like. So, by the way, notice this is the file. Notice it's encrypted, right? So, we're not passing around the clear text credentials. As I go into vCenter, you can see that if you're an EMC customer, there's this plugin, and the plugin is a single plugin that can be used for provisioning any EMC storage subsystem. And by the way, we continue to do all sorts of really cool stuff. We're going to be adding detailed performance mechanics and metrics. We're going to be adding a alignment and auto alignment function as part of the tool. So expect to see more and more, and it's going to, best of all, it's going to continue to cost $0. So if you're an EMC customer and you're not using this thing, stop. Please use it, right? It automatically configures to best practices. So I'm now going in and I'm saying, hey, I'd like to provision some storage, right? Because I installed that, enabler that gave me access. I'm going to go off and I'm going to create a LUN. The only pool that I can see is the one that the VMware, the storage team has delegated to me. And off I go. As soon as I say go, it's not only going to provision the actual LUNs, core NAS devices, again, simple, easy, unified, but present them up to the ESX cluster and properly configure every single node in the cluster. Simple. Well, why wouldn't you do it this way? Does it make sense? Like, seriously, why wouldn't you do it this way? So please, next time I come to Copenhagen, everybody, right? By the way, if you want to try it, if you go to the hands-on labs, in EMC's got a partner hands-on lab, lab number 26. Big chunks, not all, I'm not going to claim all, but big chunks of the hands-on labs run on VNXs. So if you want to find out more about how it works, it's all running on NFS-based data stores. You can go and you can talk to the hands-on labs team. Some of the EMC team is their tool. Fun people, cool stuff. There's also vCenter operations and Hyperion plugins for EMC storage stuff, which is really, really awesome. So, you guys get the idea. So, if I give us a report card, if I'm a harsh judge, we do all of those things today. The one that I didn't give us a check mark was VM object awareness in the array. Do you know anybody who does this? The answer is, EMC actually does it the best way that the major storage vendors do, which is we connect up the storage array to the vCenter APIs. But you know what? That's not the right answer. The right answer would be to make the storage subsystems natively store VM objects. There's a killer secret session, VSP3205, that I believe is occurring on Wednesday at noon. VJ and Satcham from VMware are presenting the content. If you're interested in the future of storage in VMware, check out that session. Trust me. So, last thing on this. What does the future hold for storage? That's all the stuff that we do today, right? This is a fascinating discussion. There's 3 core storage architectures there on the market from everybody. 1, classic storage blocker NAS that says as I add ESX hosts, and maybe I'm using vCloud Director on top, eventually when I have enough hosts, I expand beyond what the array can do, I need to buy another array. Classic example of this would be like an EMC VNX, an added FAS platform, blah, 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 right? An EVA. Next example is this scale-out model that says as I add ESX hosts, I scale out horizontally. Someone yell out an example of one of these. Isilon is one. What's another one? The Equalogic is an example of this idea, right? A VMAX, an EMC VMAX is an example of this idea. Architecturally, what they share in common is that you add brains and disks in some common way, right? And then the other example is an AND, which is I want blob storage, where basically you have disks in servers that get presented out as objects. Does anyone know any examples like this? Does anyone here use Twitter? Seriously, no one uses Twitter? When you do a twit pic, it goes up and it uses S3 type storage, right? Amazon S3 type storage. That's that category of storage. EMC does that too in something called Atmos. EMC Atmos, object level storage. That is very loosely coupled and therefore not very good for transactional workloads. The latency is too high. So the big question I always get asked is, why do I say SAN today, NAS emerging? The reason is that scale-out NAS models typically have not been the right way with vSphere. Now, the latest of the latest, and again, I know that I'm running out of time, so I got to wrap up. We've shown with all of these storage models, with vSphere 5, we've broken every record. So we've broken 10 gigabytes per second to a single array. So how did we do that? We basically put it through a VNX 7500, loaded to the gills, 10 gigabytes per second. That's 80 gigabits per second. That's a fully saturated UCS chassis, the Gen 1 chassis, right? We broke 1 million IOPS through a single vSphere 5 host. So how do you do that? You build a monster server, you eliminate network bottleneck, build a scale-out storage subsystem, and go. Put engineering teams in a room, let's sit. So how do we do this? Look at the server that we use for this. 96 gigahertz of CPU power in one host. 10 megs of L2 cache, 120 of L3 cache. This was a monster Westmere EX host. Intel sent over from the labs. We all had fun. I brought the pizza and the beers, and off we went. This was the storage array. The Symmetrics guys told me, you're not allowed to publish this because we took off the cool faceplates with the Cylon lights. Right? I'm like, I don't worry, it's a nerdy conference. Right? And boom, this is it under load. Right? This is a heat map. So you can see it's humming like crazy. The point on this story was 1 million IOPS through a single vSphere host is a huge number. There's no customer in their sane mind who has a single VM, a monster VM that uses that workload. But when you see VMware talk about monster VMs on the storage side, that's the benchmark that they're using against that. And there's a great white paper. Scale-out NAS models in VMware. There's some changes in vSphere 5. Again, there's a killer demo, but I'm going to skip it because I'm over time. Google Virtual Geek scale-out demonstration. It's really cool, where we're highlighting that in vSphere 5, the NFS client means that as you add hosts, if you've got the right scale-out model design, all the workload automatically moves between all of the storage nodes. And literally, we got out and shot a storage node, and it was completely non-disruptive at the VMware layer. So, I'm skipping a lot of cool stuff, but the last thing, very last, is this is just still the beginning, right? We are seeing that what's occurring now is compute workloads and storage workloads are getting mashed up. Does anyone use the VSA, the VMware VSA? So you can see some storage functions have now been implemented as VMs running on compute, right? Likewise, in case you haven't seen it, we have been running demonstrations of people running VM workloads on storage arrays. How do we do that? The storage arrays are running vSphere, right? And they're running the storage stack simultaneously as compute, right? So the lines of storage and compute are going to get blurry over time. And again, I've done a really cool demonstration of that, but we've run out of time. And you can see it again on Virtual Geek or YouTube or however you'd like to see it. Hopefully this has been interesting. What I'd encourage you to do is give me feedback on the forums. You know, hopefully it's useful. Hopefully you can see the amount of work that's going into this is insane, right? If you want to learn more about a lot of stuff, there's a lot of sessions. I'd highlight that the most important thing is I'm not a big believer in just the talk, even though we've been doing it for over schedule. I'd say play, right? If you go to the EMC lab, which is in the booth, or you go to the hands-on labs, you can try all of the stuff that I've been discussing, right? And you can talk to folks and learn more. Again, for those of you that are EMC customers, you know, thank you. Again, you know, we report our financials earnings this morning, which are great, so thank you. And thank you for being VMware customers. Very much appreciate it. If there's anything I can do to help any one of you, you know how to reach me on Twitter and on Virtual Geek. Thank you very much.